Hello folks, and today I'm going to record a new video about configuring Cisco router from scratch but using DHCP client on the outside interface. And I'll record this video a little bit slower. So I will be talking slower because on the previous videos I got comments that only 25% is understandable because I talk too fast. So I'm gonna go slow here, okay? This is for you guys who can't follow me because I'm talking way too fast. Now, this is our router, and as you can see on the router, we have connected. Hold on, where is it? And as you can see, we have connected virtual ISP. And we have a computer. Now, this virtual ISP, I call it as a virtual ISP, but in reality, this is just an interface on the firewall, on my firewall, which then translates this subnet into my public outside IP. So in reality, this cloud here has an internet. So if I'll get the IP address on my outside interface on the router, and I'll try to ping Google, I will be able to ping, because this cloud has a real internet. But of course, this IP address is just for the lab. It's 123.456, as you can see, and this is not the real public IP of mine. Now, we will be using Gigabit Ethernet 1 and Gigabit Ethernet 2. Obviously, you can see here that the Gigabit Ethernet 1 is the outside interface and Gigabit Ethernet 2 is the inside interface. And let's start configuring. First of all, let's configure the IP address on the interface. We'll do configuration terminal. Then we will need to go inside the interface configuration. For that, we usually type interface Gigabit Ethernet 1 in our case, and by in our case I mean that different platforms have different interface name. So obviously you need to type the interface name which you have on the platform. In physical routers, you will have Gigabit Ethernet, let's say 0/1 or 1/1, but here in the virtual world, in the virtual CSR, we have Gigabit Ethernet 1. So now I'm inside the interface configuration. That means anything I type is applied to this interface, unless the command that I'm typing is the global command. That means if I enable IPSSH version 2, I will be exited from the interface configuration and the command IPSSH version 2 will be applied. But anything that I type, that is the interface command, let's say IP not inside or IP address something, it will be applied to this specific interface and nothing else. Not this one, but only to this one. Okay? Now I'm inside the interface. Let's type IP address, and guess what? We want to use DHCP client, correct? Remember, this video is about using the DHCP client on the outside interface. That means ISP has a DHCP enabled. They gave us the MAC address or they didn't, it doesn't really matter. The thing is, when our router will request the IP address and sends the DHCP discovery messages, ISP will reply with the offer. And if you type IP address on the interface and use the question mark, you'll see the options. And one of the options here is the DHCP. That's what we want, right? DHCP. We can use question mark again to see if there's anything we want. Now, host name is pretty much telling the DHCP server that I am the host name, so give me the IP address for me. We don't want to use specific host name in this case, so I'm just gonna go ahead and click enter. Now, the configuration of the DHCP client is done. That's it. But as you can see, the interface is in shutdown mode because by default on this platform the interfaces are down. Well, I would say on majority of the router, if not all, the interfaces are down by default. So if I'll go and check the command to check the configuration of the interface, that would be do show run interface gigabit Ethernet 1. And as you can see, here's the DHCP configuration, and here's the command that disables the interface. Now we need to run the command no shutdown to enable this interface, and we are already under the interface configuration, and remember, we haven't exited it yet. So here, config and IF, which means interface. Now all we need to do here is do no shutdown, and this will enable the interface. So if I repeat the command do show run interface gigabit Ethernet 1, I will see that shutdown command is not there anymore. You see, it was here, but it's not there anymore. And in the log, we saw the message that line protocol on interface gigabit Ethernet 1 has changed. State is now up. And we have another message that says the interface gigabit Ethernet 1 assigned the ISP address, this and this. Now, this is my first available IP address from the DHCP pool in my virtual ISP. That's why we got this IP address. Now, if we exit from this configuration, do show IP interface brief, you'll see that our IP address is this one. Now we can ping the, let's ping the ISP, which is .1. For that, in the enable mode, not in the configuration, but in the enable. For that, in the enable mode, I'll type ping 12.34.56.1, and as you can see, it's pingable. But let's check the routing table. Show IP route. As you can see, we have static route already because of the DHCP client. Now that means if I'll type ping and Google DNS, I will be able to ping it, even though I do not have the route configuration in the running config. Show run include IP route. That means I'm searching if there is IP route part of the command inside the running configuration, and it's not there. Remember, because we haven't configured default gateway, default route. All we have this is because of the DHCP. So if we'll disable this interface, this route will go down. Not only because the DHCP IP address is not in place anymore and hence we don't have the gateway, but this is reachable through the gigabit Ethernet 1, and that is also another reason why this route will go out from the routing table. Now, since we have the public IP address on the router, which can ping Google DNS, real Google DNS, now it's time to configure the inside interface to, have the inside connections. So let's go into configuration mode again. Configure terminal. This is the full command. In short, we do conf t. And then again, interface gigabit Ethernet 2, right? But let's do short int g2. And this is the same as typing interface gigabit Ethernet 2. And let's assign the IP address for the LAN. IP address, and remember, previously on the outside interface, we used DHCP because we wanted the router to get the IP address from the ISP automatically using the DHCP client. In this case, we will actually run the DHCP on the router, and we will assign an IP address to this computer here using the DHCP server running on the router. So the router has to have the static IP address assigned on the interface, and let's assign it. For that, we run the command IP address 192.168.0.1, then space, and then we need to type the subnet mask. In our case, that will be 255 again, 255 again, and then 0. That's the same as prefix 24, which we have on the topology here. Now, remember, the interface is disabled by default, so let's enable that. No shut, which is short for no shutdown. Now, let's check the show IP interface brief again. And as you can see, we have the second IP on the router. And let me give you this tip here. This method here, that pretty much tells you how the IP address was assigned on interface. Now here, without going and checking the running configuration of the interface, we already know this IP address was assigned by the DHCP server, in our case from the virtual ISP. And on this interface, we know that this IP address was assigned manually using, running configuration. Now, it's time to enable the DHCP server on the router so the computer can get the IP address. Right now, computer doesn't have the IP address. We can configure manual IP, in case we want to test it without the DHCP, but let's configure the DHCP as well. Okay, so to configure DHCP, we have to have this subnet, which subnet we are going to use, and in our case that will be 192.168.0.0/24. And let's go ahead and configure it. Go into configuration mode and type IP DHCP pool, and then we'll name the DHCP pool. So this will be a name of this specific DHCP server configuration, DHCP service for this specific subnet, I would say. Let's say LAN. So if you notice, in every my configuration, I use uppercases when I put the value of the, name of the function or anything. That is not the command. Anytime it's not a command and it's a value coming from me, I use the uppercase, because when you read the configuration, when you do show run, it's easier to read it. And let's do let's do IP DHCP pool LAN, and if you do question mark, you see that there's nothing else after that. So we'll hit enter, and now we are in the DHCP config mode, you see. So we have to give the network now. In our case, that would be network 192.168.0.0. Remember, our subnet is 0/24. And let's put the subnet mask. Okay, now we told the DHCP server that you are going to assign the IP addresses from this subnet. Now we need to add additional DHCP options like gateway or the DNS, and let's do that. Default gateway, default router, I would say, will be 192.168.0, and what do you think the gateway will be? .1, right? Because this is the IP configured on the router. So when the computer gets the IP address, we want the computer to have the gateway of the router. The gateway IP address, we want the computer to have the router as the gateway IP address. So when the computer tries to reach out the internet, it will send the traffic to the router. So that would be dot one. Now we also want to have the DNS server, because when DNS client tries to resolve the IP address of the, I don't know, google.com, for example, we want computer to know where to send these requests. And in our case, we are going to use Google DNS and Cloudflare DNS, just in case. The command for that would be DNS server, then this is the IP address of the Google DNS, question mark, and as you can see, you can add another DNS server. And let's use the Cloudflare. Question mark again, do we need third DNS? No, 2 is enough, even 1 is enough for the lab, but let's use 2. And hit enter. Now this is it. Now DHCP configuration as of now is done. So if you'll try to get the IP address from the router using DHCP client on the computer, it will get the first available IP address. But I love to exclude first several IPs from the DHCP in case I want to use these IPs on the switch or access point or anything else that is the network equipment. And to exclude some of the IP address from being assigned to the host inside the broadcast domain, we'll do the command IP DHCP. Actually, let's exit from the DHCP configuration because it will work, but it's a global command. So we'll need to do exit from here. Now we are in the configuration mode, and let's type IP DHCP excluded address, and let's exclude the IP address starting from 192.168.0.1. Let's exclude first 50 IPs, not 50, that's too much. Let's exclude like 10 IPs should be enough. 10. Now what we are saying to the router is that when you start assigning the IP addresses from this configuration, keep in mind that you cannot assign the IP addresses within this range. So the first available IP address will be .11 for the computer. And let's check that. Here's the configuration. Right now we should not have any IP address on the interface. Oh, looks like the DHCP client refreshed, tried to get the IP address from the router already, so it got the IP address 11. Now, as you can see, we have the gateway. This gateway we have because we configured this command here. And we don't see the DNS because Windows doesn't show DNS unless you do ipconfig all. So let's do ipconfig/all, and here's our DNS servers. And as you can see, our DNS servers are the same IPs as we configured here on the DNS server. So computer knows where to send traffic to resolve the IP address of the apple.com or google.com, for example. And computer knows where to send traffic at all if the traffic destination is outside its local subnet. Now let's try and ping the gateway. So right now I'm trying to ping the Cisco from this Windows machine. And as you can see, I'm pinging. I get the replies, right? So this is on the topology, this is this computer trying to ping this IP address here. But this is not enough to have the internet on the computer. We have the gateway, we have DNS, but we don't have the network address translations. So when computer sends the traffic to the router will route the traffic to the outside interface. And my ISP here, virtual ISP, will receive the traffic coming from the 192 network. And ISP, my virtual ISP, doesn't know that this subnet lives behind the public IP. You know what? I need to change this because it's 100, not 51. Sorry about that. So yeah, so we don't have the network address translation. So because this virtual ISP doesn't know that my subnet lives behind the .100, virtual ISP will not reply. That means the computer will not see the reply, ICMP echo replies, and as a result we won't see that computer is able to ping Google DNS, for example. Now right now Cisco router is not blocking the traffic, so if you capture the traffic on this interface, you will see that traffic coming from 192.168.0.11 is leaving the router interface Gigabit Ethernet WAN. But the firewall in physical world, because this is a firewall, but in a virtual world, the ISP will drop the packets because ISP doesn't expect these IP addresses to come in. So let's configure the NAT on the router. And to configure the NAT, what we do, we need to have the access list. It's not to give the access, but it's to be used to match the traffic. Because in a Cisco world, you use the access list to match traffic sometimes. You don't use the access list only to give the access or take away access. Pretty much, I would say almost always, the access list is being used to match the traffic. And then when you match the traffic, you do whatever you want with the traffic. In our case, we go into configuration mode again, and we will use the extended access list. Why? Because I love using the extended access list. It gives you flexibility. IP, for to configure the access list, let's do IP access list, and then we do extended. If we do question mark, you'll see you have different options here, and ours is extended. And then we can name it. We can use numbers, which is the legacy. Back in the days we didn't have the named access list, but now we do have it. So it's pretty cool to name the access list instead of just using the numbers. So let's name it, and let's name it in a way that we can recognize this access list is for the internet access list in the future. That would be internet NAT ACL, and then question mark if you want to see what's going on after that, but there's nothing. Now, if you do remember, or if you know how to configure the access list, extended access list, you know that the first we need to type is permit, because permit is what matches the traffic. Deny is what doesn't match the traffic. In our case, we want to match the traffic so we can perform the network address translation operation on it. So we do permit. Then we do, what do we want to permit? What do we want to match? If you use question mark, you'll see that you have different protocols here. You can choose pretty much any of the configuration, but in our case, we want to match the IP configuration. So this is what we want. So we are going to type here IP. We don't want to match any other configuration. We could use TCP, UDP, and ICMP, but we have no reason to do it right now because we want to match any IP configuration. So permit IP, question mark. Now here you put the source IP address. In the source IP address you can put host, object group, any or a specific IP address, or the subnet. I hate to put any in the network address translations because that's not our best practice and sometimes it causes the issues. So let's use this specific subnet. In our case, if you remember, our subnet is 192.168.0.0/24, and we want to match this subnet as the source subnet, right? Remember, we are from the computer going to the router. The router will see the source subnet is this one, and the destination is gonna be anything else. So we'll type here 192.168.0.0, and then let's use the question mark again. Now here we want to put the wildcard bits. Now this is the reverse. This is the kind of like subnet mask, but written in a different format. So for you to understand, if it's 255.255.255.0, the subnet mask, in a wildcard, that would be 0.0.0.255. So let's type it 0.0.0.255. So what we are saying here that anything that starts with this match, and we don't care about the last bit, we really don't, it can be anything. And this is the matching IP protocol from this subnet. Now, we want also to match the destination, right? Because we want to catch traffic that goes to the internet. Now, what traffic goes to the internet? Do you think we have to use subnet specific or the any or the host? Of course we use any. By the way, you can put 0.0.0.0.0/0 here and it will convert into any. But in our case we just do any, and then we do question mark, and then it asks what do we want also to match, and we'll just hit enter because that's enough information for us. And if we'll check this access list right now, do show access list, internet NAT access list, this is how it looks like. Permit IP, source subnet, and destination any. So it doesn't matter where we go, we have only one exit here, so it definitely goes to the internet. So anything that goes towards the virtual ISP, we want to match the traffic. Okay, now we have the access list. Let's use this access list to actually perform the network address association. Let's exit from the access list, and the command to enable the NAT, like globally using this interface, will be IP NAT, and then we do inside. Why? Because this is the inside address association, like the source address association. We type inside, and then we type source, and here we want to give the list because we created the list. We don't use the static or route map, we use the list, access list, and this list command is for the access list. And after list, obviously we need to use this access list name to match the traffic. You see, remember the extended access was supported, it was supporting the numbers, but we used the named access list. So that's the name we want to use here. So that would be IP NAT inside source list internet NAT ACL space and question mark again. Now we want to tell router into what translate our source IP address. Now we can translate into a pool, which we don't have. I mean, we can create the pool and then translate the IP address into that pool, or we can translate the IP address into interface IP address. Let's use interface. And we'll choose the interface. In our case, the public interface, if you remember, was Gigabit Ethernet 2, not 2, 1 actually. So we want this subnet, entire subnet, to be translated into this IP. And for that, we'll choose Gigabit Ethernet 1 here. So here's the full command. IP NAT, sorry, there's extra symbols here. IP NAT out inside source list internet NAT ACL interface Gigabit Ethernet 1. And you can do question mark. And here's the thing. This overload command is here by default. Because we translate entire subnet into an interface, we need to use the overload. Now, what does it mean is that when we translate first IP, in our case .11, into public IP, we are not done with that. We also want to translate .12, .13, .14, and that's why we have this overload command here. We can put overload here, or we may not. It's still gonna be there. So let's skip the overload command, and then we'll check the configuration to confirm it's there. Now, NAT configuration, global configuration is there. So let's check that configuration. Do show run IP NAT inside source. Now, what I'm saying is run the show run command from the config mode. Now, this do is here because we are not in the enable mode, we are in the configuration mode. And anytime you do show commands inside from the config mode, you need to use do. So we are saying do show run and then pipe, and we say include, this I means include, anything that has the NAT inside source. So pretty much this command that we entered here will be visible. Let's see the enter. And here's the full command: IP NAT inside source list internet NAT ACL interface gigabit Ethernet 1, and the overload command. Remember, we didn't put this command. It wasn't there, but it's by default right now because we are translating entire subnet into one IP only. So we cannot afford to lose the NAT after first translation. So Cisco will put this overload command by default there. Okay, you would think that this is enough to have the internet, but it's not. And to confirm that, I'm gonna show you the ping command again. And as you can see, we don't get the replies. Now, for reason for that is, even though Cisco has the access list, the IP NAT is not enabled by default on all the interfaces. In fact, it's not enabled on the interface, on any of the interface at all. So we'll have to tell Cisco on which interfaces we expect NAT configuration to work. Show IP interface brief. In our case, this is the outside interface and this is the inside interface, and that's what we are going to tell Cisco. Conf T interface gigabit Ethernet 1. So we are under this interface right now. We are saying that, hey Cisco, use this interface for the NAT outside. IP NAT, and guess what? We type outside. Okay? After outside you have nothing. Now we need to do the same, but for the inside interface. Let's go interface gigabit Ethernet 2, and here we type IP NAT, you guessed it, inside. In this scenario, if I remember correctly, that's enough. We have NAT configuration on the interface, outside interface. We have NAT configuration on the inside interface. We have global NAT configuration. We have the access list, right? We have the public interface into what we translate, and we have default route. Pretty much all the conditions to have the internet through the router has been met. Let's try and ping Google DNS again. I think I'm not missing anything. And sure enough, we have the internet through this router. So now this computer using the DHCP client, using the DHCP-assigned IP address, can go to this router to reach out the internet. And here's the fact, we can do that. You'll think that this is done, this is it. Cisco configuration is done, but we need to add some extra, little bit security. I'm not going to run the firewall, zone-based firewall on this router right now, but we can do some little work to make it more secure. Let's start by enabling the AAA configuration to have the username and password authentication method. For that, we go conf-t and we do AAA AAA new model. Now this will enable the new mode of the authentication that supports authentication, authorization, and accounting. But we'll just use the authentication. And let's put the username. Username will be, to add the username command will be username question mark. See, now we are required to put the real username, like the username we want to use to log in on this router remotely. Because right now we are using console cable, remember? This putty here, this putty here, oh come on. This putty here is the same as the console connection to this router. So the username will be Cisco and then question mark. You see, you have a bunch of options here, but all we need to do is to use the password. But we are going to use the secret. Now, what's the difference between these two? The password saves the password in the running configuration in the plain text. That means whenever you do show run, you will see the password. Now, of course, there is a command to encrypt that too, but it's decryptable. You can, even if it's encrypted using the global command that encrypts the passwords, you can still get the hash and decrypt it using the decryptable tools on the internet. But if we'll use the secret, that's not as easy as decrypting the password. So we'll use secret here. And our password will be, I don't know, Cisco123. Now, if we do show run, we'll see the username, but we won't be able to see the password, that the password is Cisco123. Let's confirm that. Do show run include username. So we are checking all the configuration and searching for the line that includes the username. And here's our configuration, username configuration. We have username Cisco, and then we have secret 5 and hash, like hashed password. Now, as you can see here, we have 5. That means the MD5 hashed secret will is following to this line. So this is pretty much MD5 of my password, which is Cisco123. Where is it? Here, this one, right? Now we have the username and password. Do you think that's enough to log in on a Cisco router? It should be, except one thing. We don't have the DNS, not DNS, we don't have the enable password, but let's try. So on the Windows, I'm typing Telnet. I'm not using SSH client. Keep that in mind. I'm using Telnet because Telnet is still enabled. I'm using Telnet, and by the way, Telnet is not enabled on the default. By default on the Windows, you have to enable that. You go into programs and features, and then you enable the Telnet client. And then Telnet 192.168.0. What is this? 1. And here's the username prompt. We put Cisco, and the password will be uppercase C. Come on. Let's put the password, and we are on the router, but we are not in the privilege mode. We are not in the enable mode. You see, we don't have this sign here, pound, right, or DS or whatever sign it is. And if we'll type enable command, it won't work because we don't have the enable password. So let's put the enable password as well. Enable, and again, just like with the username, you have options password and secret here. And of course, we are going to use secret. And our enable password will be, let's say, Cisco again. Now, if we repeat the command here, enable command, it will ask us a password. You see, because the router has already a password, so it will be able to authenticate. Let's put Cisco, and sure enough, we are on the Cisco router from the Windows using the Telnet protocol. I didn't tell you that I hate Telnet. Yeah, so Telnet can be used for things, but we don't want to use Telnet to access the router or switch or anything that, you know, is the network equipment, because Telnet doesn't encrypt the data. So if you're capturing traffic on this interface here, on this cable here, you will see the Telnet password, and I think I have video on that. If I don't, I'll record another video for that, how to see the passwords in the Telnet. But yeah, you can see that. And because of that, we want to disable Telnet and enable SSH only. But you cannot just enable SSH. SSH requires to have the domain name and the crypto key that will be used. Now, if you try to configure the crypto key without first configuring the IP domain name, it won't work. And now I'm going to show you crypto key and generate RSA. This is how you configure the key for the to be used in the SSH question mark, and we'll just hit the enter. But it doesn't work because actually we didn't even change the host name, so we have to change the host name and then give the domain name. Our host name will be R1, so we just changed the host name of the router. It's R1. Now if we repeat the command, we'll get the new error that says you need to have the domain name. Oh, actually it does. Oh, you know why? Because we actually have domain name. Remember, we configured the outside interface using DHCP client, not the static manually configured IP. And my DHCP server gave the DNS name, domain name, to the router. So router has the host name which we just configured and also has the domain name from the DHCP server of the virtual ISP. And because of that, configuring the host name and then following the crypto key generate RSA is enough to configure the key without, applying the command IP domain name, just like we did in the previous video where we configured the outside interface manually using the statically manually configured IP address. We want to make it as complex as possible, so we'll use the maximum bits. So right now the router was generating the key that will be used to encrypt and decrypt the SSH traffic, and it's done. Now if you'll go into LAN VTY, which is the configure the management, I would say access, in our case 98, this is the maximum allowed virtual lines. Here we have to enable the SSH and not enable the Telnet. Now, when I say not enable, that means we exclude the Telnet from the command. There is no command to disable Telnet, but there is command not to enable Telnet. So transport here will tell the LAN VTY virtual lines which transport protocol, which protocol we'll use to access the router. We can have Telnet, SSH and stuff like that, and we'll just use the SSH. And we want this for input, so when we access the router, transport input, and you can have all, you can have Telnet, and we will have SSH only, and we don't enable Telnet, just an SSH. Now If we exit from here and try to log in again, we are not able because we hate this telnet. Now let's open the put here and use the SSH client. You see, SSH. If I'll go to telnet, it's gonna be the same as from this command, command line window, and it won't work. So we'll choose the SSH and hit the open. And here, this says that I have a new key coming from the server, in our case from the router, which I don't recognize because, you know, we just created this key. Are you sure that you know where you're connecting to? So this is a good warning if you're connecting something else. Let's say you already configured SSH, you already been on the router, but then for no reason you get this message. That means now you're connecting to the host that has the different key, and that could be the different device which is trying to steal your passwords. So that's why we have this warning here to understand that you know, we don't recognize this key yet, but that's okay. We know we don't recognize that. We know it's freshly created a key. So I'm gonna say yes, I'm sure, let's do yes. And the request is to put the username, in our case Cisco, password, uppercase Cisco 123, and again, enable mode and Cisco. Now we are on the router, but using SSH, not Telnet. We can do pretty much everything what we were able to do from the console, and we can actually do it faster. Like if you do show run, you see how super fast it is, but if you do show run here, it's a little slower. It's actually still fast, but in real world it's much slower because you have 9,600 bits per second, and it's pretty slow. On SSH you have like, I don't know, 100 megabits, whatever you have Ethernet speed. Okay, we have configured SSH and we have disabled the telnet. What else we can do? Well, we can limit the access to the router from a specific IP. Let's say we want to access the router from this Windows machine only. For that, let's configure the access list that includes IP address of the computer. Let me exit from here. We do conf t again and IP access list. And in this case, I will use standard access list, not the extended. And the reason for that is we don't want to match the protocol or destination IP address. We only need to match the source IP address, because we want to tell router that only this Windows machine, the Windows IP, can log into you, nothing else. And we don't really want to tell using which port, which protocol, stuff like that, because router already knows that only SSH is enabled, there is no telnet, so we don't have to specify the port. So to make it easy, we'll use the IP access list standard, not the extended, question mark, and we can use numbers or the name. I'll use the name again. That would be VTY filter, because I like descriptions in the values. I want to recognize this access list and know what is it for when in the future when I do show run command. So this is the access list. Now let's permit the IP address of the Windows machine to match the traffic. And permit. And because this is the standard access list and not the extended, you don't have these protocols, source and destinations and equal ports, stuff like that. You only have permit and IP address. In our case, we'll do host because we want to match only one IP. in case you want to allow the access to entire subnet from entire subnet, you would use, something like this. And then I think it's prefix. No, it's a wildcard. And then something like this. But I want to allow access to one IP only, from one IP only. So that's going to be permit host and then IP address of the Windows. And I think it's .11. Is it? Yep, that's 11. And that's it. That's the access list. Now, remember the virtual lines on line VTY? That's where we want to assign this access list as a filter for the incoming management traffic. This is the configuration we did to enable the SSH. And we want to go to the same place and configure the filter. Now, you see how this is split into two pieces? I think it's because of the back compatibility. For many years, Cisco had 4-line VTYs only. Then they made it 15, and now they have like 98 or something like that. And different platforms, they have different numbers. That means how many sessions you can have simultaneously connected to the router. And it splits. Even if you do from 0 to 98, you're saying that I want to configure all the line VTY lines with the same configuration. It still splits. So when you copy and paste this configuration into all the routers, this will work, but this will not. So we can do 0 to 4 and then from 5 to 98, or we can do from 0 to 98, which we will do. Now let's assign the access list to filter the incoming management traffic. For that, we type access class. And here we put the access list name. In our case, that's the access list name, right? VTY filter, remember? And we want to include direction. Is this for the incoming management traffic, or this is for the outgoing traffic when the router generates the traffic and goes out? Of course, in our case, that's incoming traffic. And then end. Now, we still should be able to log into this router from this Windows machine using SSH, but we should not be able to do the same from different IPs. And let me show you the match of the interface, not interface, the access list. Put the wrong password. So show access list VTY filter. You see how you have the match here? That's because we are coming from this IP. If we'll change the IP address here on this access list or on our computer, we won't be able to log into this router anymore. So be careful, don't lock yourself. If you're not sure that you are doing it correctly, you can do permit any after this line. So if you're coming from different IP because you're translated into something in the middle before you reach the Cisco, you will still be able to log in and see where do you have the hit counts, where do you have the matches, and then remove permit any and leave only the IP you want to have. But yes, so we limit the access on the management. And let's now block some unnecessary traffic coming from the outside. So we want to put the access list on the outside interface. Let's create the access list. We'll use the extended access list, of course, because we want to be flexible and tell which protocol on which port we are allowing and which not. IP access list extended again, and let's name it outside filter in. This is just a name of the access list. And now let's permit. What do we want to permit from the outside? Let's do show IP interface brief. Remember, we translate all the traffic into this IP, and then traffic will come back towards this IP again, so router can process the NAT. So the reply packet, reply traffic will have the destination IP, this guy here, but the source IP can be anything, and we want to match that specific traffic right now. So let's permit TCP, and I'll explain why TCP. Coming from any location, going to the host of the router IP. So you're saying, David, but you're allowing all the TCP connections from the outside wall to the router, so what's the point of having the access list? Now, here's the point. Instead of hitting enter, we are going to type the command established, which is this guy here. Now, this will match only the traffic that is already established. That means if the TCP session is generated from the computer or from the router and goes out, and that TCP session has the reply, that reply will be allowed will be matched by this access list, and we can allow the traffic. So it will not match the new traffic that has the sync messages in it, but only the reply packets or maliciously generated packets, but you got the idea. Established. Okay, we can allow the TCP connections, TCP replies. That's cool. Now we also want to allow the ICMP replies, right? So we want to ping the router from the outside. Well, if we want to, of course. You may not want, but if we want to, we do permit, and instead of TCP, we choose the protocol. You guessed it, ICMP. Again, from any location, again, to the host, this router IP, and equal. No, actually we don't have equal. We just put the equal. And we can do echo or echo reply. Now, if you put echo, you will be able to ping the router from any location. But if you put the echo reply, you'll just be able to get the replies from the outside world, but you won't be able to ping the router. So if I'll do echo and now ping Google, when I assign this access on the outside interface, I will be able to getting the replies, but I won't be able to ping this router from the ISP, for example, because I allow echo reply only, not the echo. Now let's allow the DNS packets, DNS replies, because when we try to go to google.com, for example, we want to send out the request from the DNS client stating that I need the IP address of the google.com, and that reply is supposed to be delivered to the computer here, and we need to allow this reply. So how the DNS reply looks like? Well, it's going to be, what's wrong with this keyboard? It's going to be UDP, of course, and then it's going to be from any location, or actually we can put DNS, Google DNS and Cloudflare DNS. Let's do that. So we want to allow replies. Well, you don't really put the reply here, but let's match the reply traffic of the DNS requests. Permit UDP from host Google DNS, then equal And what's the protocol? What do you think? This is the protocol. No, the port number, I mean, not protocol. This is the port number 53, because that's the port DNS client, DNS service uses to resolve the IP address. So we put 53 here. You can put domain or 53, it doesn't matter. It will change the domain again. And then we want to put the destination. So in our case, destination is again the public IP address of the router. So destination would be this guy again. And then hit the enter. We don't want to add any equal stuff like that. Why? Because that's enough. Now we want to repeat this command for the Cloudflare DNS IP address. Because if Google DNS goes down and we want to reach out the Cloudflare, we should be able to get the reply from that Cloudflare IP address as well. Okay, let's see how the access list outside filter in looks like. And this is the access list. Permit TCP replies, permit ICMP replies, permit DNS replies, and permit DNS replies. Now, obviously, this is not a firewall. This is a simple, very simple access. It doesn't even include everything that you need to include as a best practice. For example, in order to have the working trace route and stuff like that. But this is the minimum you can apply to the interface without running the full zone-based firewall on the router. And now we will assign this access list into a public interface. That's the interface, remember? So let's go to this interface and let's assign the IP access list. For that, we do IP access group. This is how you assign the access list to the interface. And then we put the name of the access list and we put the direction. So if we put out, now every time traffic leaves the router, it goes and matches against the access list. And since we don't filter what we send to the internet, but we want to filter what comes back, we want to put in here. And that's it, enter. Now, if you reply the command of checking the access list, we have several matches already on the TCP established. Why? Well, because Windows is constantly trying to reach out some different servers, like, I don't know, Microsoft, or maybe some application updates and stuff like that. So we already have the match. Now we can have the match on the echo reply as well if we'll ping the Google DNS from the Windows machine or from the router itself. It really doesn't matter. Both will, match the traffic access list. Let's ping Google DNS. That would be 4 packets by default, remember? And let's reply the command. I don't know why we have 3 matches. We have to have 4. 1, 2, 3, 4. Yeah. Oh, here's. We have 4. It was some delay. But we have 4 matches. Now, if you go to Google DNS, if we'll try to open the browser, we'll have the matches here as well. Because, DNS client from the computer will try to resolve the IP address. So let's try and resolve the IP address of the google.com. Are you saying that you cannot resolve that? Oh, it doesn't work. Let's troubleshoot that. Okay, can we? Google.com. We cannot. Did I make a mistake here? Okay, what's the DNS again? Okay. Oh, here you guys. this is the wrong IP address. So we are matching the wrong destination IP in the DNS replies, and because of that, of course, the real traffic is not allowed. So let's go ahead and fix that. So we want to remove these two lines, no 40 and no 30. This will remove line 30 and line 40. Keep in mind that you don't have to put the no entire line. You can put no and then this line, or you can put no and 30. Also, you can put no and entire line, but you don't need to do that. Now let's repeat the command, but fix the IP address. The same for the cloud DNS, and I fixed the IP address. Guess what? It opened the Google search again. Not again, already. So if I ping Google, oh, come on. I know it's working, right? It just takes some time because, you know, my virtualization is slow. By the way, why am I not getting the ping replies? I'm getting. Well, it's slow because my virtual server is not super fast. So, and this Windows virtualization are also slow. In reality, the traffic, we don't have these drops. So I can ping it from the Cisco, for example. You see, I can ping from the Cisco, and traffic is, you know, reply. It took some time. You know, this is when you have the virtualization instead of the real world. But yeah, you see how fast it is? It's like, I don't know, 15 millisecond maximum. When in reality here you have like, I don't know, 2 or 3 seconds. But we don't care about that. We don't work on the speed, we work on the configuration. So now if you check the access list match, we have match on the DNS replies, we have match on the ICMP replies, ping replies, and we have match on the TCPs. We pretty much allow the minimum traffic. We have the minimum security right now. I would not put this in a production, but this is a start. If you don't know how to configure the zone-based firewall, at least you should have this access in place. And usually, you better understand what configuration you have on the router. Each line you use on the router, you need to know what it does. And since these lines are pretty easy to understand, that's all we use now for today. Now let's save the configuration. To save the configuration, we can do copy running to startup, which tells the router that grab the running configuration and paste it into startup file. So when the router reboots, it will have the same running configuration. We can do this command, or we can do write, which is the legacy command of doing the same as copy running to startup. And I usually do write. Now everything is ready, and this is how you configure the Cisco router from scratch using using the DHCP client on the outside interface when the ISP has the DHCP server. Thanks for watching, and put your questions in the comment sections. Have a nice one.